Yay. Okay, great. Sorry for that. Hello, good morning. My name is Leonie. I'm a German living in Dubai, the United Arab Emirates, and I work for Cloud and Heat Technologies. We build the most energy efficient liquid-cooled data centers in the world with focus on sustainability and security. Today I was given the opportunity to talk about pushing the boundary conditions of data centers, facilitate innovative circular economy approaches. And I would like to take the opportunity to thank the whole team, which is Dr. Jens Struckmeier, Dr. Andreas Hantsch, Anne Weisemann, as well as Konrad Wächter. It's been a pleasure working with you guys. I know you are watching virtually right now, live from Germany, so thank you guys. Well, today I would like to talk about a very disruptive and innovative technology concept, which we call energy to data, data to X, X being heating, cooling, or water. But what does this actually mean, right? I kindly ask you guys to pull out your smart devices, for example, your phones. I'm waiting. Yeah, and touch the back of it intentionally. It may feel warm, hot even, right? So that's called excess heat or waste heat. And imagine if this can be doubled or tripled. Imagine a data center. We have so much more computing power equals to much more excess heat or waste heat. And we looked into that. So roughly 10 years ago, we started to figuring out how we can use that waste heat of a data center by heating buildings, really. Our first use case was the former European Central Bank in Germany, Frankfurt, where we have a water-cooled or liquid-cooled data center on the ground level, and we heat the whole building, which is pretty cool, I think. And just recently, we also discovered and researched a way to apply this concept for hot regions, right? I mean, the heating demand, for example, in Dubai, the United Arab Emirates, it's not the same such as in Germany. So how can we leverage the waste heat in hot regions? And we found a way we could use it for cooling via an adsorption chiller, or even for producing water. And this is only possible with our technology, which is direct hot liquid cooling. So today I would like to look at water in more detail. We are leveraging the server waste heat of data centers to desalinate seawater to get potable drinking water. How exactly will this work? Well, the data centers are directly liquid cooled with our technology, and the waste heat is captured within the liquid up to 60 degrees Celsius, and then it is transferred to desalinate to produce potable drinking water, which is carbon-free, by the way. The waste heat drives the whole desalination plant to produce the potable water, and we only need a very minimal amount of electrical auxiliary energy for pumps and measurement and controls. So here you can see a direct comparison between our very innovative and disruptive liquid-cooled technology to traditional and less effective air-cooled technology. So our direct hot liquid cooling is directly attached to the server blade, as you can see here, and connected to the RAM, CPU, and GPU via a pipeline, thus cooling it directly and efficiently. And the entire system then is installed within a whole micro data center, which is easy scalable. We have conducted some experiments, which we would like to share with you today. And here you can see an exemplary representation of a cooling system. And it shows that roughly 70% on average can be used for heat capture rate of electrical energy for heating purposes. So now I would like to talk about the 3 key takeaways of this experiment and the paper, essentially. So first, in warm climates, we can use almost up to 100%, for the scientific crowd, 99.9% to precise, of the electrical energy. And this is because we are capturing, again, the waste heat in a liquid via this compression type system. And the same is not so much possible in cold regions, just because of the free cooling component. Second, the higher the chip temperature, the higher the exit temperature, so the more effective use of waste heat. And third, we can apply the whole concept globally. I mean, again, the warmer the better, right? The warmer the region, the better and more effective use of the waste heat. But still, in colder regions, we have a heat capture rate of 85%. So still 85% can be used for waste heat applications, such as heating, cooling, or water. So finally, I would like to take a moment and illustrate the potential, what I just indicated earlier. So remember when I started saying I'm a German living in Dubai in the United Arab Emirates? So that's in the Gulf, right? We have almost no rainfall there. So almost every drop of water I consume, I need every day, is produced artificially by a desalination plant. And for example, in the United Arab Emirates, 1/3 of the domestic oil production is used for desalination purposes. I mean, it's insane, right? And imagine we could fix that. So what we did is we did an additional study, an analysis, and we found out that we just need 40 megawatts of data center, which is retrofitted or new ones, equipped with our liquid cooling technology, use the waste heat to cover the whole bottled water consumption of the entire United Arab Emirates, just with this solution. And by the way, there are 10 million people living in the United Arab Emirates. So that's pretty amazing, as I think. So the call to action is quite clear. We call upon the server and chip vendors as well as manufacturers to optimize for liquid-cooled high-temperature systems. Because again, that's a global potential for revenue, but also for sustainability. Thank you.
Okay, we've got about 2.5 minutes for questions.
So, bottled water is great, but we're in the middle of a drought here now. What do you think about scaling it up further than that?
Yeah, that's a very good question. Thanks for that. That is a point I wanted to mention, but apparently I forgot. So the idea is to start with a kind of a pilot, such as the United Arab Emirates, and then it's easy to scale as a blueprint to other hot regions, because essentially you just need to do it once, and then you can scale it if you have, again, low heating demand, but high computing demand. So such as California, such as United Arab Emirates, Singapore as well. So all those places with a very strong sustainability agenda as well, in terms of governmental regulations helps. In terms of Singapore, we have exactly the same situations like in the United Arab Emirates. And this blueprint can then easily be used for other regions as well. And again, it's not only a call for sustainability, it's a business model.
You have 40 megawatts of data center. The power is coming from a power plant. If it's a thermally produced energy, you'll have much higher grade heat from the power plant itself at 300 Celsius. Have you considered using that for desalination?
Yeah, so that's also a very smart question. Well, we are smart soft and hardware experts. We are not so much in the desalination industry, so that's a next step we definitely have to do. We are searching other verticals, such as talking with the expert of the desalination verticals to get to know maybe how to do this more efficiently even. That's exactly, I think, what the next steps could look like. Thanks for the insight.